So we're still looking at factoring, but how we're going to look at factoring is slightly different than how we looked at it before. Now, obviously, if you're looking at a problem on a test and the directions say, factor the following by grouping. Well, grouping is where we chop it in half and we do each side, and that's what you should do. But the realistic perspective to factoring is that the instructions will just say factor, and it will be your job to decide what type of factoring it is. Okay, so if it's 3 terms, how did we say yesterday we would factor 3 terms? A times C, right, trinomial, and we have to decide if it's a shortcut or not. How do we factor 4 terms? Yusuf? Oh, how do we factor 4 terms? Grouping, right, split in half, grouping. How many terms does it have to factor a GCF?
3.
4. Any, right, yes, right, it can have any amount of terms. So our GCF is sort of this one that's a little bit more difficult to figure out. So here are going to be our rules we're going to sort of start with today for factoring. If we are given instructions that just tell us to factor, the very first thing that we are going to do is to look for a GCF, because a GCF does not have restrictions based on the number of terms. Okay, so the first step that we're going to do is look for a GCF. Right, so one of the things we did on the first day of the unit was decide if it had a GCF or not. Right, they always have a GCF, but if the GCF is 1, it's kind of pointless to write down. Okay, so we're going to look for a GCF. If it does have a GCF, if we say yes, there is a GCF, then that's the method we want to factor with. And we are going to factor out a GCF. So we're going to give ourselves a quick reminder here just to make sure we're good to go. So let's say we have 12x to the 4th plus 16x squared. Does this have a GCF? Yes. Right? What is the GCF? 4x squared, right? Because what goes into 12 that also goes into 16? 4. Do they both have the variable? Yes. Smaller exponent? 2. So yes, there is a GCF. So we are going to factor that out. Right? To factor it out, we divide. So 12 divided by 4 gives us 3. We subtract the exponents. Anything go into 3 that will also go into 4? No. So we know, well, 1, right? 1 is our actual answer, but we don't need to do that as a step. And so this would be our answer for factoring out a GCF. Okay, if we look at the problem and we say, no, you know what? I don't see a GCF. Then you'll skip step 1. All right, there's nothing to factor. You just skip it and you move on. Step number 2 says now let's count the number of terms. So if we count the terms, and there are 3 terms. Eric, say it again. What do we do with 3 terms? It's a trinomial. So if it's a trinomial, we're going to have to decide if we can use the shortcut or not, which is what we did all day yesterday. Right? When do we have to rewrite it? When can we use the shortcut? That's what we'll do in that category.
The variable at the variable end, yeah.
Mm-hmm.
That's what I was confused.
Yeah, sorry. Maybe if we do this. Sorry. If we count the number of terms and we get 4 terms.
Then you factor out GCF.
What do we do with 4 terms?
Wait.
Grouping.
Yeah.
So lots of my students might forget the word grouping, but at least remember that this is where we split it in half.
What's the shortcut where you had the 1 times the C?
Mm-hmm. Mm-hmm. So if that A in front is a 1. Mm-hmm. So let's say we're given this problem and we are asked to factor it. Okay, so step 1 says, look for a GCF. Does this problem have a GCF?
No.
1.
It's 1C.
1C. So does it have a GCF?
Yes.
Yes. So we should factor out the GCF. Right, you can write the 1 here if you want to, but the 8 is left over. 2 minus 1 is C. Plus 7. Anything else we can factor out?
No.
No? So we're done. Okay, so if we look at this one, step 1 says look for a GCF. Do we see a GCF? No, right? They don't all have the variables, so we know we can't pull out a letter. And they don't all have a common factor other than 1, right? Even if we get close and we think 2, it doesn't work over here. So no GCF. So we skip step 1 and we go to step 2. Step 2 says count the number of terms. 4 terms. So how do we factor 4 terms? grouping, so we're going to split it in half.
And then divide the left side by 3.
Okay, so we're going to look for the GCF over here on the left-hand side.
3A.
3A. We said this before, but hopefully we're kind of like factoring out GCFs in our sleep. Because at this point we've only done a few hundred of them, right?
And then the other side you will do 5.
So when students ask me how I can see the GCF so easily, right? Think how long I've been doing this. I've done like hundreds of thousands of them.
The other side.
Okay, so now we'll do the right-hand side. What's our right-hand side over here?
Negative.
Negative 2, right? Because our leading one is negative.
And then it's 3A minus 2.
Yep, so we'll get a 3A minus 2.
And then A plus 4.
Okay, do we sort of get the idea of how the list is going to work? Yes, Yusuf.
Okay, so if you're like 100% sure that like you did like the first part of it right, can you just find the GCF on the second one and just be done? Cause like the other one.
Yeah, I mean, if you're 100% sure that it's factorable by grouping, and you're 100% sure that you did it correctly, yes. Okay, but there's going to be some other pieces we introduced that might change your mind on that in a little bit. Not today. Later. Okay, so now let's go back to the POD problem. Let's see, 3x squared plus 15x plus 12.
Are we allowed to use our notes tomorrow?
Yes, absolutely. Okay, so step number 1 says look for a GCF.
There.
Is there a GCF?
Yes.
Yes.
Yes, which is where some of you got the idea that we could factor out a GCF. Right, so let's factor out a GCF. What is the GCF?
3.
3.
And then the other thing.
Okay, nothing else we can do, right? Yes, Yusuf?
How to use both?
Well, we're going to do that. Okay, so now, let's pretend that this is sort of similar to prime factoring. I mean, it's not sort of, it is. But we just have polynomials. If we wanted to prime factor 20, what would we split this into?
1 times 20.
Okay, so 4 times 5, fine, whatever. 2 times 10 is fine.
Split 4.
Okay, can we stop here?
No.
No.
No, we keep going. So that's the same idea we want to consider over here. We split it 1 time into 3 times all of this. So now let's focus our eyeballs here. And let's count the number of terms that is.
3.
Right? Because when I'm splitting up this 4, does this 4 have anything to do with this 5?
No.
No. So when I'm splitting this up, it has nothing to do with this 3. So how many terms is this?
3.
3. How do we factor 3 terms?
Multiply.
A times C, right? So 1 times 4 is
4.
4. Can we use the shortcut on this one?
Yes.
Yes. So we know this splits into a 1 and 4. So we'll have an x plus 1 and an x plus 4. So here's my step 2, right? What pieces over here are part of my final answer?
The 5, 2, 3.
This 5 still counts counts even though it's from the row above. So when I'm going to write my final answer, this 3 still counts because I couldn't break it up anymore.